Hello everyone, myself Dr. V. Vijayalakshmi, Assistant Professor in Mathematics from Hindustan Institute of Technology. In this video, I am going to explain about basic definitions, Eulerian graph and Hamiltonian graph in graph theory. Basic definitions. Path. A path in a graph is a sequence of vertices v1, v2, etc. vn. Each vertex is adjacent to the next vertex. Also, all the edges in the path are distinct. Cycle. A path which originates and ends in the same node is called a cycle. In this example graph, let us know some paths from V1 to V7. One path is V1, V2, V5, V6, V7. Another path from V1 to V7 is V1, V3, V4, V7. You can write the path V1, V3, V7 also. In this example graph, the cycle is V1, V2, V5, V6, V7, V3, V1. The another cycle is V1, V3, V4, V1. You can write any number of paths and cycles for a graph if it is possible. Connected graph. A graph is said to be connected if every pair of vertices connected by a path. Otherwise, it is said to be disconnected graph. First one is the example for connected graph. Here, every pair of vertices are connected by a path. Second one is the example for disconnected graph. Here, V2 and V5 has no path between them. V3 and V6 also don't have any path. So, this is the example for disconnected graph. Eulerian graph and Hamiltonian graph. Eulerian cycle. A cycle in G which contains all the edges exactly once is called Eulerian cycle. Eulerian graph. Any graph containing Eulerian cycle is called an Eulerian graph. In this example graph, the Eulerian cycle is V1, V2, V3, V4, V5, V3, V1. In this sequence, all the edges are appeared exactly once. So, this is the example for Eulerian graph. Hamiltonian cycle. A cycle in G which contains all the vertices exactly once is called Hamiltonian cycle. Hamiltonian graph. Any graph containing Hamiltonian cycle is called a Hamiltonian graph. In this example graph, the Hamiltonian cycle is V1, V2, V3, V4, V5, V1. In this sequence, all the vertices are appeared exactly once. So, this graph is example for Hamiltonian graph. Let us consider this Eulerian graph. Here, we cannot construct a cycle which containing all the vertices exactly once. So, this is the example graph for Eulerian but not Hamiltonian. Next, consider this Hamiltonian graph. Here also, we cannot construct a cycle which containing all the edges exactly once. So, this is the example graph for Hamiltonian but not Eulerian. First one is the example graph for both Eulerian and Hamiltonian because we can construct a cycle with all the vertices exactly once. Also construct a cycle with all the edges exactly once. So this is the example for both Eulerian and Hamiltonian. Second one is the example graph for neither Eulerian nor Hamiltonian because we cannot construct a cycle with all the vertices exactly once, also with all the edges exactly once. So, second one is neither Eulerian nor Hamiltonian. Thank you for watching.